Let's take another example on small changes. We are given that the modulus of rigidity G is equals to R raised to power 4 theta over L, where R is the radius, theta is the angle of twist, and L is the length. Determine the approximate percentage error in G when R is increased by 2%, theta is reduced by 5%, and L is increased by 4%. Now we see that G is a function of R, theta, and L. Therefore, the small change in G is approximately the partial differentiation of G with respect to R multiplied by the small change in R plus partial differential of G with respect to theta multiplied by small change in theta plus the partial differential of G with respect to L multiplied by the small change in L. Now with this done, the things we evaluate first are the partial differential. So let's evaluate the partial differential with respect to R, and that will be dr of R raised to power 4 theta over L. Since we are differentiating partially with respect to R, then theta over L will be constant, and then we have a full differential of R raised to power 4, and this will give us theta over L multiplied by 4R raised to power 3, and this will give us 4R raised to power 3 of theta divided by L. Now let's evaluate partial derivative of G with respect to theta, and that will be d theta of 4 raised to power R raised to power 4 R raised to power 4 of theta divided by L. Since we are dealing with theta, then R raised to power 4 over L are constant, and a full differential of theta with respect to theta, and that will give us R raised to power 4 over L multiplied by 1. That's R raised to power 4 divided by L. And finally, partially differentiated with respect to L, that's R raised to power 4 theta divided by L. In this case, R raised to power 4 theta is a constant, and the L of 1 over L. This will give us R raised to power 4 multiplied by theta into minus 1 over L square, and this will give us minus R raised to power 4 theta divided by L squared. Now let's take a look at the small changes. R increased by 2%, theta reduced by 5%, L increased by 4%. So if R increased by 2%, then the change in R is equals to plus 2, that's 2, divided by 100R. And if theta increases, reduces by 5%, and that will give us minus 5 divided by 100 theta. Likewise for L, which increased by 4%, this will give us 4 over 100 L. To simplify further, this will give us 0.02 R. This will give us minus 0.05 theta, and this will give us 0.04 L. So going back to our formula for small change in G, we have that delta G is equal to the partial derivative of G with respect to R multiplied by the change in R plus partial derivative in G multiplied by partial derivative in G with respect to theta multiplied by the change in theta plus partial derivative of G with respect to L multiplied by the change in L. Then we make our substitutions. The G, the R is 4R cubed theta divided by L, and delta R is 0.02 R plus the G, the theta, which we have as R raised to power 4 over L multiplied by delta theta, which is minus 0.05 theta, plus the G, the L, which is minus R raised to power 4 theta over L squared. Then we are multiplying by the change in L, which is 0.04 L. So when we simplify further, we have this to give us 0.02 R raised to power 4, 0.08 R raised to power 4 theta over L minus 0.05 R raised to power 4 theta over L, and this should give us minus 0.04 R raised to power 4 theta over L. And the small change is approximately R raised to power 4 theta divided by L of 0.08 minus 0.05 minus 0.04. Therefore, the small change in this is minus 0.01. Now, R raised to power 4 theta over L from the question is equivalent to G, and this minus 0.01 is equivalent to minus 1 over 100. Hence, we can say that the approximate percentage error in G is a 1% decrease.